And so enter the particle wave duality. By saying that this is a particle, we've introduced a problem into the nature of reality, because it's not actually a particle, it acts like a wave. Since Michelson and Morley didn't find the luminiferous ether, which they were very upset about, science assumed that there wasn't an ether, that there wasn't a medium in which matter traveled. Now, Morley went to his grave thinking that there had been some type of mistake, that he had overlooked something in the way that he was approaching it. And Einstein worked very hard trying to sort this out, and was kind of convinced from the beginning, I believe, that there wasn't anything that light was actually traveling in. And I think that Einstein made a mistake about that. I think that there is a medium, there is a substrate, and the reason that it's not detectable is very obvious in astrotometry. The problem with the Michelson-Morley experiment is very obvious when you apply the concept of the node pattern to it. In astrotometry, there is a waveform that is set up from an underlying waveform that is the carrier wave. In other words, there's a carrier wave in which the particle is sort of, it's not bobbing up and down, but it's being translated through space across the space that is surrounding it. In other words, it gets translated through the space around it by a carrier wave that's underneath of it, and that it's not the particle that's actually moving. It's the pattern of the particles that's moving. And the pattern of the Earth's matter is phase locked with any light that would be striking it, anything that comes in from outer space. And when it isn't, there's an anomaly. There's something that's called the flux transfer event that's seen when there's a discrepancy between the energy that strikes the Earth and where the Earth is going to be, or where the matter of the Earth is going to be. There's a shift that happens on the physical level from in what in astrotometry is considered to be the stuff that moves the Earth through time. See, this goes back to the nature of electromagnetism. If you look at the electromagnetic wave, it has two components. It has the electrical component and the magnetic component. Now, we know that the electromagnetic part of it, light, something at the frequency of light, for example, will move at the speed of light in a vacuum. It has a constant velocity. And the magnetic part of that wave, if it's in the visible spectrum, is very elusive. And we don't really know that the magnetic part of the wave isn't attached in some other way. And in astrotometry, it's theorized that the magnetic part of the electromagnetic wave actually moves much, much, much faster than the electrical part of the electromagnetic wave. And so there's two different pieces to the waveform. And these two pieces work together to produce the phenomenon that we perceive as persistent matter. When we see matter persisting in time, or when we see it moving relative to some other form of matter, it's theorized in astrotometry that the magnetic force is intricately involved in that movement. Now, Einstein tried to sort this out with the unified field theory. And the way he approached the unified field theory is through something called teleparallel gravity. In other words, there's this concept that Einstein worked out to approach the unified field because of the nature of the photon spin entanglement. See, Einstein was really, really bright and realized that the light we perceive as coming from outer space has to function the same way as the light that we can test here on the Earth. And so the spin entanglement of the photon has to be conserved through time-space, which means that light has to have some type of other side to it. And Einstein supposed that gravity was somehow teleparallel, that was his concept, with the electromagnetic force. And so this is how he approached the unified field, which was brilliant. It was a brilliant way to approach this. The issue that that I think Einstein missed is that time itself has more than one axis. There's more than one kind of time movement. There's more than one sort of movement through time, because on the physical level, on the level of the movement of an object. In other words, as matter persists in time, it doesn't have to move relative to something else, but something is still moving. There's something still moving that makes it persist in time. And that is the chronodifferentiated movement, the chronodifferentiated motion in astrotometry. And there is a nominal version of this, which is why we have inertia. There's a sort of the concept of inertia is that there is a nominal or normal chronodifferentiated motion. This is what we perceive as the rotation of the Earth and the precession of the Earth around the Sun, or the primary time axis. Now, the concept is that there's an electromagnetic field that surrounds the Earth at an arbitrary distance, and that field actually connects the Earth with itself in other times. So in other words, the magnetic part of our electromagnetic field actually connects the Earth to its present and future, or to its past and future, and that those connections aren't visible because of the nature of that movement. It's the movement that we perceive as changes in the patterns that form our three-dimensional existence. But the connections electromagnetically are why we have cause and effect in our world. In other words, the reason that we can perceive the cause and effect of something, the reason that something that happened a long time ago can affect something right now, is because of these connections that are actually physical in nature. And so when you think about an earthquake, if you think about the movement of the continent, it resonates with itself through time. If you speed it up, it looks like it's just one motion, right? It has a frequency to it that is, it's slowed down to us. If you for example, let's say for example that someday California is going to fall into the sea. That's one of the theories that the geologists say. If you could see that over time, it might just look like it's falling into the sea. But to us, it's a lot of little movements. And those little movements are separated in time because of the scale of time that we see. And so that movement, the one movement, is a form of inertia. There's a sort of inertia that movement has with itself through time, eons of time. And it's electromagnetic in nature. And since the Earth, if you think about the sun as static, and you think about the Earth as going around and around and around and around, if you think about it like that, and you think about how that electromagnetic field interacts with itself through time, you can see that when the sun's on one side, or when the Earth's on one side, when it's on the opposite side, there's a relationship there. There's a crisscrossing of the electromagnetic field that the Earth makes with itself when it's at the opposite side at a different time. And so that is what the sun is in astrotometry. In astrotometry, the sun is this hyperdimensional form of the Earth's electromagnetic field that resonates with the frequency of hydrogen primarily, because hydrogen is primarily what is moving on the Earth. Hydrogen is primarily what is changing, which is primarily the movement of the seas. And this is why I have related the coronal mass ejection to the formation of the cyclonic storm. Now, I realize that if you just got what I'm saying, you're probably going to be running, screaming from the room.